At this time, I'd like to present Jim Chisholm, the chair of the West Toronto chapter, who will be introducing the next speaker. Jim?
Thank you, Bernie. How long did it take you to get here today? Now, those who stayed in the hotel don't have to think about it. Probably a while, eh? So take a second to think about, on your regular day, how long does it take you to get to work? Well, a recent study in the GTA indicated that it takes about an hour and a half of commute time to get to work each day. This is significantly more than cities such as Boston, Los Angeles, and Berlin. The same study found that commute times and related infrastructure problems cost Toronto $6 billion every year. A sobering thought, indeed. Our next speaker, Eric Miller, will shed light on some of the issues and choices regarding transit in Toronto and how to optimize the Toronto network. Eric is the inaugural director of the University of Toronto Cities Centre. He has been a professor in the university's Department of Civil Engineering since 1983. Eric has held a number of additional roles, including director of the UOT's Urban Transportation Research and Advancement Center and acting chair of the Department of Civil Engineering on 3 separate occasions. Eric is well-versed on transportation issues. He chairs the Washington-based Transportation Research Board Committee on Travel Behaviors and Values. And he is a member emeritus of its Transportation Demand Forecasting Committee. In addition, he recently chaired travel demand modeling peer review panels for magnetic levitation demonstration projects in Pittsburgh, Baltimore, and Las Vegas. He has been a member of technical advisory groups for the TransSims implementations in Portland, Oregon, Buffalo, New York, and Burlington, Vermont. Other numerous assignments, such as travel demand peer reviews, have focused on Los Angeles, Baltimore, Cincinnati, Salt Lake City, Denver, and Vancouver. Closer to home, Eric's GTA model, a best practice regional travel demand modeling system, is helping Toronto, Mississauga, Brampton, and the region of Durham to forecast travel demand in the Greater Toronto area. Eric has a BASC and an MASC from the University of Toronto and a PhD from the Massachusetts Institute of Technology. Please help me welcome Eric.
Thank you, Jim, and thank you very much to all of you for inviting me here. It's my great pleasure to be with you today. As the introduction indicated, we have significant transportation challenges in this region, and what I hope to do in the next few minutes, as quickly as I can, to think through the problem a little bit. And anybody from the Toronto region knows that, particularly in the city of Toronto, over the past year and a half or so, we've been going through, in my mind, what's been a very foolish and wasteful and not very helpful debate about what to do about transit. And we certainly need to do a lot about transit. We have basically not invested in transit, particularly in the city, for a long, long time, literally decades. And as we'll see in a minute, the region and the city have been growing tremendously, and our our infrastructure, both road and transit, simply haven't caught up with it. So we need to do something. But the problem with the recent debate has been that it started from the wrong point. And it started with an ideological debate about technology, that subways are good, light rail transit is bad, or vice versa. And as an engineer and as a planner, I found that very disturbing, because transit design should not begin with the choice of technology. Technology is one of the elements in the overall design process. And what we're dealing with is a very complex social, economic, political, and very much technical system and design problem, and if we don't look at it in a holistic way, and if we don't understand the context of the travel market we're trying to serve and the technological alternatives available to us, we're doomed to failure. And so what I want to do today is expand the design problem and show where technology fits into the overall problem, so that we can ultimately make better technological choices. But in particular, emphasize that the design problem is not one of technology per se. What we're trying to do is design a transit network, and the services that that network is trying to provide. And that's why in this diagram I've put it in the center and showed transit technology is one input into that overall design problem. But there's many other elements, and it's not just a technical problem or strictly a transit problem, because the reason we're building the system is to serve the population employment, the urban activity system that consists of urban form, and the people and and the economy and the characteristics of those people in the economy, and out of these characteristics interacting with the transportation systems being provided that we get travel demand. And there's a demand-supply interaction going on between the transportation system we provide and the needs and activities and desires of the people and the economic system that give rise to a very dynamic interaction between demand and on the transportation system. And we have to understand that interaction if we're to design the system properly. Similarly, and so then sitting at the heart of this is the transportation system. And of course, there's a very large component of the financial policy and decision-making environment that influences, that determines what we actually do build, and the financial component of that is a particularly important one. This is not something I'm going to be able to talk about much today, just a brief comment or two. But what I really want to focus in on those first two parts. First of all, understanding the context within which transportation functions in an urban region, and then coming to the question of how to design that system. So I want to talk a bit about demand and transit ridership. Where does transit ridership come from? I want to talk briefly about that urban context, the built form. It's not just a transportation problem, it's a city building problem. It's how we build and structure our city determines what we can do with transportation in general and transit in particular. I do want to talk about some basic design considerations for transit, and then working towards that technology choice. So if we want to talk about, if we look at travel demand in the region, as Jim mentioned, this is a region that's been growing tremendously, but we haven't invested much. The reason we have so much congestion, the reason it takes so long to get to work, is the urban area has been growing by about 100,000 people a year for the last 20 years, and is projected to continue to grow that way for the next 20 or more years. And yet we've invested very little in either road or transit over that period of time. We've been adding the city of Kingston to the Greater Toronto Area for each year for the last 20 years, and it's no wonder. And without adding transportation infrastructure, it's no wonder that you get stuck on the roads. So we see, if you can see these numbers, it's very hard to see very little increase in infrastructure, whereas at the same time we've had almost a 50% increase in population. Auto ownership has increased over that time period, and the overall trips have increased at that rate. So we have 50% more trips than we had 20 years ago. But transit hasn't kept up with that. Transit and walking and biking haven't kept up with that because most of that growth has gone on in suburban areas. It's very auto-oriented, very little or no transit, very difficult to serve by transit, as we'll see. And so while the region's been growing, we've been forced basically through our urban form and where that growth has been going on, combined with a lack of investment in infrastructure, into an auto-dominated society. And the trouble is, as urban regions get to the size of Toronto, the auto system simply doesn't scale very well. We can't build enough highways to carry everybody, and so we have to be looking for transit solutions. We have to be looking for changes in our urban form, but that's a very challenging problem. This is, again, a very difficult slide, I think, to see, but the basic point is that over that time period, everywhere across the region, auto mode shares have gone up, market shares have gone up, except in downtown Toronto, and similarly, transit modal shares have gone down everywhere except in downtown Toronto, where there is good urban form and good transit has been available. Again, this is impossible to see, but if you actually could see the numbers, what you'd see is in terms of transit usage, about 45% of all transit trips in the Greater Toronto Hamilton area are trips to or from or within the Toronto downtown. And another 24% are to sort of the inner ring of East York, York, and North York. And so transit is largely used in areas that have reasonable density, as we'll see, and already have an existing good transit system. Outside of that, it's very auto-dominated because of the suburban urban form that we have. And so if we look at what the factors that affect transit usage, it's really pretty straightforward. Access, egress, walk time. All transit trips start with walking to a transit or perhaps driving, and then they all end with a walk from the transit system. Wait and transfer times. You have to wait for the bus or you have to transfer to the subway. Reliability. Will the bus or the streetcar or whatever it is arrive when you expect it to arrive? The crowding and capacity constraints. If you're jammed tightly packed into a very standing room only vehicle, that's not very attractive. The door-to-door travel time is also important to us. The fare is important, and the characteristics of the trip makers are important. Not all people are equal, but different people have different preferences for transit. In particular, certain people are much more transit dependent than others. Our transit system is not necessarily built to supply the transit to meet the transit needs, particularly of lower income people without cars. The young, the elderly, and so forth. So some of the people who are potentially most transit dependent, the current service does not necessarily address them. I'm not going to talk more about that here today, but it's something we should be very aware of. I'm not going to talk about fare policy either, but the others I'd like to briefly talk about. People don't walk very far to transit. They'll walk up to about 500 meters. Downtown, they'll actually walk. They will actually walk up to about 800 meters, about half a mile. And so this is and if we look at the walk egress, it's a very similar sort of thing. And so this is one of the big challenges in terms of transit. We have to have coverage. We have to have a transit network that's ubiquitous enough that it's within reach of people in terms of walking to and from it. We need stop spacing. We need a density of of transit lines and a density of stop spacing that allows people to be able to get to and from transit. This is particularly important at the egress end because at the home end, maybe we can drive to a parking station, maybe we can get a ride or so on. But at the egress end, the work end of the work trip, walk is basically the only way we can make that final few hundred meters or whatever it is. And this is a particular challenge outside of downtown areas, in suburban areas, for reverse commutes. The GO train system carries many people into the downtown and carries very few people out, because if you take the train out to Oakville, what do you do when you get to Oakville GO station? You can't get to where your final destination is. This is just simply illustrating the dependency on walk mode of transit, except for GO Rail, in the commuter rail case, a significant amount of access is by car, either by being driven or driving and parking. York Region also has significant auto access to transit. So one way of getting around problems, at least in terms of access to transit from the home end, is through providing park and ride lots and so forth to increase the accessibility to transit in suburban areas. Wait and transfer times are very important. When you get to the bus, once you've walked to the bus stop, you have to wait for the bus. And the general assumption is that people arrive somewhat randomly at the bus stop, and the buses are on time and maintain their headway frequency. And so under those circumstances, the average wait time is about half the headway. So if a bus comes every 5 minutes, on average, people wait 2.5 minutes. And for short headway, high frequency services, that works not too badly. But one problem is very often we can't afford to provide high frequency services, and so the frequency of the service is often low. And so once you get beyond, much beyond 5, certainly 10-minute frequencies, the wait times become much larger, and the reliability and the dependability of the service, the attractiveness declines. And so there's a real challenge in terms of not just providing a bus or providing a service of some sort, but providing at a level of frequency that's attractive to people and that they're willing to take advantage of it. In addition to the initial wait time, when you get to that first bus, we very often have to transfer. And in the Toronto system, that's particularly the case given kind of our grid network. We very often have to transfer. And the reliability of those transfer times is very, very important as well. And studies show that there's a psychic cost, a transfer penalty in people's minds, over and above the actual amount of time you might take to walk from one bus to the other and wait for the second bus or the subway or whatever the case may be, is the psychological factor, the risk factor of, well, will that second bus come, or will it be reliable on time, adds to people's psychic costs. So it's not just the wait time, but the sheer fact that we have to transfer can be problematic. Service reliability is huge, and this is something we don't talk nearly enough about. It's one thing to talk about, in our models that it takes this amount, we think it's on average it's going to take this much time, but if there's variability in that, if buses are supposed to arrive every 5 minutes, but maybe it's 10 minutes before a bus arrives because of bus bunching and so on, this adds extra wait time, and that reliability factor is very important to people, because this means if the service is unreliable, you have, in terms of when you leave to go to work, you have to leave earlier than you need to, quote unquote, because to allow for the unreliability. If the bus comes early, that's fine, but that means you get to work earlier than you had to be. You could have been home having another cup of coffee. Obviously, if it arrives late, then you're in big trouble. And so building in those buffer factors for the unreliability of the service is very important and adds further to our travel times. Further, if we don't have the capacity on the system and you can't get on that first bus or the first subway train for that matter, that adds extra wait time and extra unreliability, extra stress, extra crowding, which again makes transit less attractive. In the recent debate in City of Toronto, there's been a lot of talk about travel times and particularly travel speeds. Certain technologies are faster, quote unquote, than others, but that's what speed affects is the station to station, stop to stop travel time, and obviously that's important, particularly over longer distances. But what's important, surely, to the trip maker is the door-to-door time, and again, that includes the walk time, the wait time, the actual in-vehicle time, and many transit trips are relatively short. And so that speed is somewhat less of a question. But also, the other thing to keep in mind is those out-of-vehicle travel time components, the walk time, the wait time, in addition to being significant numbers in their own right, again, psychologically, people weight them more heavily than the in-vehicle time, usually by a factor of 2 or more. So if it's a 5-minute walk to the bus stop, in people's minds, that's the equivalent of 10 minutes of riding time in general. And so that, again, those out-of-vehicle times, the wait times, which are affected by frequency, the transfer times, the accessibility times are very, very important in people's calculations. This just shows the effect of speed over different distances. I mean, and speed is important, but on a typical trip, the difference between, for example, a light rail transit speed of maybe 24 kilometers per hour on average and a subway speed of maybe 32 kilometers on average is maybe 3 to 5 minutes on the trip, depending on the trip distance. And so in the overall scheme of things, well, obviously you want things to go as fast as possible. It's maybe not the dominant point of the overall question. Finally, I mean, we've been told that people like subways, and which is true. I mean, we all like subways, but in fact, and if you actually look at people's choices, there is almost no evidence of a modal bias in terms of people having a pure preference for one mode of transit over another. What they want is a mode of transit that is reliable, that gets them where they want to go, when they want to go, connects them from place to place. And what they want is good transit service. Subways generally are reliable, generally are fast, and so they have the criteria that people need to are looking for in their transit service. But there are many other ways of delivering speed, reliability, convenience, comfort, and so on. And so it's those fundamental attributes we should be looking at in our design of our service, not just necessarily that one mode or another is the only answer. So if we put all of this together, what we're saying is it's a multidimensional problem. It's wait time, it's walk time, it's travel time, it's reliability. How do we? And there's obviously trade-offs in any design between those things. What we can do is we can try to bring these things together, and this is what we actually do in our travel demand models to build. What we call a utility function, a generalized travel time or a generalized cost, a generalized score for how one service versus another, one mode versus another, transit versus auto compares, and we can actually build probabilistic models that predict the probability that somebody in a given situation will use one mode or another, given the characteristics of the transit mode, the characteristics of the auto mode, characteristics of the walk mode, and so on. And these are the models that we actually build and use in planning. And this is a typical sort of model. The red curve is showing the probability of choosing transit. The horizontal axis is the difference in the utility between transit and auto. So negative, the left-hand side means transit is worse than auto. The right-hand side is positive. It means the transit actually scores higher than the auto. And not surprisingly, as the relative utility of transit goes up relative to the auto, more people are likely to use it. And again, one of the key points here is that it's the relative utility. If transit takes 40 minutes to get you to work, what's really important is what's the travel time by auto. If the travel time by auto is 15 minutes, then transit's very, very poor. If the auto also takes 40 minutes, well, then transit's equally attractive. And so all these things are a relative component to this that we have to understand. The other key thing from this curve is the far left indicates areas in which transit is very, 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 very unattractive. And investing in that to try to upgrade that to get into the center section where transit is very competitive with auto. I mean, where we'd like to be is in the center section or to the right, where transit's even dominating auto. Getting from that left-hand side to the center can be very expensive and can require a huge amount of investment. And in fact, a fair bit of investment, can move you along that tail, but it doesn't seem to buy you a whole lot in terms of transit usage. And unfortunately, that's the situation we're in many of our suburban areas. All our suburban areas are out in that area. Transit's very inferior to auto, and so the challenge is what can we do about that to try to move those areas into the center section, and that can be a non-trivial thing to do. So moving quickly along, because I don't have much time here, and I've got a lot of slides, I did want to talk about urban form just a little bit. And just try to illustrate this. So what we have here are three maps. The upper left is showing trips. The dots are showing trip origins of trips going to downtown Toronto. The top right is similarly showing the origins of trips going to Square One in Mississauga. The lower left is showing trips to the Pearson industrial area. And what we see is in to the downtown area, which is the largest employment center in Canada and in the Greater Toronto area, we have a huge concentration of trips. And there's a transit, because there's so many trips and they're so concentrated on one place, and they're also concentrated around major corridors, which is kind of graphically illustrated in the top here, that if we get concentration of trips along corridors to major activity centers, then transit, as we can see in the graphs down below, the tall ones there are showing the transit modal shares to the downtown are very high, whether we're talking morning peak period or all day. But But by the time we get out to a suburban employment center such as the Pearson area, which is in fact not only the second biggest employment center in the Toronto area, it's also the second biggest in Canada. It's a huge amount of employment out there, but it's very dispersed. The trip origins to those locations are very dispersed. So even though there's a lot of trips going there, they're coming from all over the place. They're scattered. They're not concentrated, and so they can't be well served by transit. And we see that that there's almost no transit usage to that area. So again, this just illustrates that because of the suburban nature of that area, it's not transit supportive. If we look at if we try to characterize, one way we try to characterize urban form is in terms of densities, and usually these days we take population plus employment, because both population and employment generate travel. And if we take the combined density of population and employment per hectare, this is the population distribution in the Greater Toronto Area. Darker means denser, and based on some people's scales, the potential for transit and the type of transit that technology that might work in these areas is illustrated here. This is a very qualitative scale, a judgmental thing, but it's somewhat illustrative. And if we look at where the current subways are in Toronto, up Yonge Street and along Bloor Danforth, we see that in fact, of course, downtown there is very high density, but both up along Yonge and along Bloor, we have reasonably high densities, but not excessively high densities. And yet these subways are in fact very, very successful, but they're successful for many reasons. We have a good combination of even though it's medium density, it's mixed use density, so there's lots of generators of traffic along these things. But it's also that the subway is part of a hierarchical network, and I'll talk a bit more about that in a minute. There's lots of buses and streetcars and so on feeding into these, particularly into the Bloor Danforth, and so these are the trunk lines that are carrying a lot of traffic and connecting people together in a sensible way. So the network design makes sense. The network is connecting people to places and where they want to go. So what does this mean for transit network design? We talked about the behavioral things. People are interested in walk times and wait times and travel times, reliability. On the network design side, that translates into attributes such as connectivity. Does the network actually connect you to where you want to go? Hierarchy, capacity, frequency, and so on. So these design attributes map in various ways into the behavioral attributes that people are interested in. They also, of course, map into the cost effectiveness of the system, the cost of the system. So connectivity, I mean, does the network actually take you where you want to go? Can you access and walk in some way? Can you get to your final destination? Can we minimize transfers? And in practical terms, how we try to accomplish connectivity has to do with stop spacing, route alignment, and the efficiency of our transfer points. The notion of a hierarchical network is very important. And what we mean by that is we need a systematic combination of buses, streetcars, LRT, subway, commuter rail, where as we move up the hierarchy, we're going for longer distances, higher speed, longer stop spacing, and because the only way we can get higher speeds is typically by stretching the stops out so we're not stopping and starting so often. But at the other end, we need that fine grain of the buses, local buses, and the walk network as far as that goes in order to be able to get to a station, get you on the system as quickly as possible. And then we need transfers between these. So you have the local bus that provides that fine-grained access and egress that connects to higher speed that takes you over the longer distances as you need it. The Europeans and the Japanese and various other people around the world are very, very good at this. I mean, I think the Germans are, this is part of the Munich network, it's not even the whole one, are very good at building this hierarchical one because it's the only way from an engineering point of view to address these conflicting trade-offs of we need this fine-grained access, but we also want to have speed over longer distances. And one thing we used to do reasonably well here, in fact, one of the reasons the TTC had worked very well was they were actually very good at having a fine-grained bus system that connected very well to the subway system. And so we were actually able to get away with a very small subway system that hit above its weight because it had good connectivity to the local bus system. Through cutbacks, combination of cutbacks of those services, plus the growth and demand, that service doesn't serve us quite as well, and we need to be adding to it. But the basic design was there. We need to build on that. One way, the best way of getting speed is through exclusive right-of-way operations. So giving one way or another, giving priority to transit. That doesn't mean we have to put things underground. We can give priority and exclusive right-of-ways at street grade as well. This is part of the design problem. Putting something underground becomes extremely expensive very quickly, but obviously there's competition for road space. We have to look at those trade-offs very carefully. So again, the design challenge is how we can take, particularly in suburban areas, coming back to my demand graph, from that left-hand side and start moving it to the right so we attract sufficient numbers of people to make it worthwhile. And again, this is unfortunately our typical design problems. We're way over to the left, and how do we move to the right? And so if we want to improve transit service, there are a whole bunch of ways we can do this. And different parts of the design component will address wait times, walk times, and so on. And what we, again, need to be doing is thinking about it as a comprehensive design problem. Where can we best put our money? How can we best improve things that will attract the most riders in a cost-effective way? So again, coming back to technology choice, it's not a flavor of the month thing. It's not 2 legs good, 4 legs bad. That there is that one technology fits all situations. We have to fit the technology to the context. And in particular, we have to ask the question: what are the 2 dominant questions about technology when all is said and done? Is the capacity? What capacity do we need to provide? What will be the demand that needs to be met? And how much is that going to cost? Speed and service frequency are important, but we can address those in a number of different ways. This just illustrates a streetcar. We've heard a lot about trolleys and streetcars versus light rail transit. This shows a streetcar, the current Spadina streetcar, versus what will be going in on Spadina. Light rail transit has very, very significant attributes relative to the streetcars we know downtown. And this is the debate that we have been engaged in Shepherd Avenue and elsewhere. Try to decide what we should be doing out in Shepherd Avenue and Scarborough in general. And again, there's no doubt the subways provide very high capacities, good reliable service, but they're also very expensive. And so it's a classic engineering problem of what are the trade-offs between benefit and cost, capability, and different ways of meeting the objectives of the system. This shows roughly the capacities in terms of peak riders per hour for different technologies. Subway has capacities heading up to 40,000. Very difficult to justify subways with less than 10,000 people per peak hour, and we see the various others. SRT there stands for Scarborough Rapid Transit. This is where, in the particular case of the Shepherd Avenue options, this is where all the demand forecasts lie, is down in that region. Over and above all the other arguments, the demand in that region, in that area, simply didn't justify a subway construction. And in particular, if we look at the cost effectiveness of the investment, if we had built the subway out to Scarborough City Centre, it would have actually attracted more new riders per year than the LRT was projected to present. But when you look at the costs, it would cost 3 times as much. And so at the end of the day, for every new rider attracted to the system, you'd pay twice as much using subway technology versus LRT. So in this corridor, it's very hard to justify that, because even though you say, well, we could get more riders, but if you took that same amount of money, invested it in other corridors in a cost-effective way, you'd end up with that same amount of money, you could get many more riders if it had been invested in different ways. And so the argument was it's better to spend less, be very effective with that money, and have money left over to do things elsewhere. And this illustrates, I think, another part of that I'll come to at the end in a minute or so, is that another problem we have here is we keep looking at partial problems. The Shepherd debate was looking at one little corridor with an entire system. That's no way to you're all engineers, if you just look at pieces of the problem, you're going to sub-optimize all the time. So if we have any hope of optimizing the network, we have to start thinking about this as a network, looking at it as a system, and not focusing on just 1 or 2 ideas in one little corridor at a time. We have to start thinking about it as a system and see how we can best cost-effectively use it. I think this is just, again, from the recent Shepherd debate. I think the part of the problem too, and this is, it was apples and oranges, that the technologies were going different places. There were completely different alignments. The subway was going to continue the existing subway and dip down to Scarborough City Center. The LRT would run all the way along Shepherd Avenue. So the route alignments aren't even the same. But in terms of coverage, the LRT reaches a lot more people than the subway would in directly. But coming back to the question of demand and understanding your market, this just illustrates the sort of situation that we face in Shepherd these days. This is showing the current travel patterns, and the future travel patterns will grow, but are actually projected to show very similar spatial distributions. The black lines show sort of northern Scarborough separating out southern Scarborough. And if we look at northern Scarborough, which is the catchment area for Shepherd Avenue, over a third of all trips stay within that neighborhood. And another almost 20% go to southern Scarborough, and some 12% go up to Markham, 12% or 6% go downtown. This is 24 hours, and in the morning peak period is about 12%. So the major travel patterns in this area that cry out for more transit are really local ones, and the connectivity to places like North York City Center is very secondary. And so a transit plan should be looking at these demands and saying, how do we best serve the current and future demands in this region? Similarly, if we look at South Scarborough, it's the same sort of thing. Well over a third stay locally and travel to different parts of Scarborough and so on. And so surely we should be building a transit network for Scarborough in particular, the city in general, that's actually meeting the travel patterns. I was part of the Shepherd Avenue panel, and I pulled these slides together, and it came as a revelation to everybody in the room. Nobody had bothered to look at the travel patterns. So we had this huge debate about technology and what we should be doing and spending billions of dollars, and no one, as far as I could see, understood the travel market that we were trying to serve in this situation. And so surely we need to do better than that. So if we do want to improve transit service in the region, this is where I'll wrap up. I think there's three big things. First of all, there's all sorts of short-run improvements. Forgetting the long-term major billion-dollar infrastructure investments, there's lots we can be doing to improve the existing system. Certainly in the city of Toronto over the last number of years, we've actually cut services. Demand has been going up and services have been cut. It's not a very good business model. So there's tremendous bang for the buck for speeding up the buses, speeding up the streetcars, providing real transit priority to the streetcars in particular, but also the buses. We have a little, we could do much more. My mentor was Professor Richard Soberman. He always talked about, a $15,000 Honda Civic with one person in it trying to make a left-hand turn, sitting in front of a $4 million streetcar with 50 people on board. What's wrong with this picture? We have to start thinking about how we can move the most people the most cost effectively and who should have priority. So there's tremendous things we can be doing in terms of the street system and transit. We do need much more higher order transit within the City of Toronto. We need a hierarchical network. We need billions of dollars investments. We're making a good start. We are now going to be building light rail transit lines on Eglinton, Shepherd East, and Finch West over the next few years. That's going to be a massive improvement in infrastructure, higher order infrastructure in the city, but we still need more. We need more north-south. We do need more capacity into the downtown. So our job is not yet done, even though we're engaging in an $8 billion investment in transit over the next 4 or 5 years. That's just the start in terms of what we need to do. Similarly, out in 905, once you get outside the City of Toronto, big plans. Metrolinx has big plans for out there, and we similarly need big investment. Viva in York, Brampton, Huron-Ontario LRT, there's lots of projects out there. Again, we're talking $80 billion worth of investment in the region over the next 25 years. Absolutely needed. But again, I think we have to keep that demand model curve in mind. Everything we're talking about out there is over in that left-hand side and that tail. It's going to take a lot of investment given the urban form out there, and it's going to need changes in that urban form. Densification, more mixed use, establishment of corridors and nodes. We're going to have to change the way we build our Mississaugas and our Markhams, and they're starting to do that. They recognize that if that $50 billion transit investment is going to make sense. So big challenges out there, but there is growing impetus to do that. And so the real challenge is, are we going to be building a transit-oriented future that maybe looks like this, or are we going to stick with what we're doing right now? And Jim's hour-and-a-half commute isn't going to look at, well, pale in comparison to this. I might note that this, is existing services in Europe and elsewhere. This is someplace in the United States. These are, current situations someplace. And so finally, I'll find that a plea, and what I, every time I talk to anybody about any of this, is my final plea is what we really need is a plan. And some people say we've been planning for the last 20 years, we haven't done anything, but maybe we haven't planned properly, and maybe we don't pay attention to plans. But I mean, at the regional level, we have the big move, which is a great start as a comprehensive regional plan, a strategic plan. But particularly within the City of Toronto, we need to get back to thinking about this system and thinking holistically about the system, and come up with that hierarchical, comprehensive transit network, and stop talking about in a piecemeal way about this project or that corridor or this technology. We have to sit back and look at the network, look at the demand, look at the land use, look at our aspirations. Similar to the previous conversation about what are our aspirations as engineers and educators of engineers, we have to think about our aspirations for our city, for how we want to move around this city, and then think about how do we get from here to there. And so with that, I'll conclude, and hopefully there's time for questions.
Thank you, Dr. Miller, for your excellent presentation on the transit technology and choices. My question is that, Dr. Miller, from your research and analysis, can you give us your insight about the fares amount paid by taking the transit? Do you advocate pay by distance travel, or as now the one fare system for the whole transit system?
Well, that's a good question. I guess I have slightly mixed feelings, but I do think in the long run we have to go to some sort of fare by distance. I mean, the GO transit system is already that way. Many systems in the world are that way. The fact is, longer distance trips cost more to provide, or more costly to provide, and so I think we have to get to that point. I mean, the TTC used to have a zone fare system way back when. In the early 70s, they went to a single fare. That's when they started to have operating deficits. Before that, they actually paid their way out of the fare box. I know the counter-argument is you're trying to encourage people in suburban areas, particular longer distance trip people, to take transit, and so in a sense maybe it's worth subsidizing them. But I think at least we have to recognize that there is a subsidy there if we don't do fare by distance.
Hello? Yes, here. Yes, well, Dr. Miller, thank you. Excellent analysis. I really appreciate the holistic approach that you've taken. At the risk of talking technology, I am concerned about how we are ever going to mix rail and road at the same grade. There appears to be very serious problems of getting it in when you have a developed city already. And there appears to be problems operating it when you have cross streets and interferences of various types. So would you say a few, and by the way, it does seem, although it's cheaper, we seem possibly to be externalizing cost on the users rather than biting the bullet and perhaps spending more on subways. So would you explain a little bit and briefly to us how you think road and rail can coexist at the same grade?
Okay, well, it does depend a bit on the width of your right-of-way, but certainly in our suburban regions, we have very wide right-of-ways, and so there's space there. At-grade LRT systems are operating around the world in many cities in Europe, including Paris and various, even Madrid, other places. So there's LRT systems are operating in something like 115 cities around the world. Not all of them are at grade, mixed with streets, cars right beside them, but many of them are. I think it's So I think it's definitely doable. There may be some trade-offs with the ease of movement of some cars in some situations, but again, I think it's a question of priority. You look at a street and you think, oh my goodness, there's all these cars. Well, maybe there's 30, 40 cars there. That's one that's a 1/3 full LRT vehicle, so it's very easy to think, oh, we're creating all this congestion, when in fact, if the LRT system's actually effective in what it's doing, it's carrying many, many, many more people. One lane of LRT can carry, somewhere between 5,000 and 10,000 people an hour. One lane of traffic carries about 900 cars an hour. So there is I think if you do it right, there's a very serious trade-off there to take advantage of. But I'm not saying it's not easy. But again, to put things underground, maybe we should put the cars underground. Why do we put the transit underground? Grade separation, obviously, grade separation is good. Vertical. If people want to put something up top, let's put it up top. We have to be thinking three-dimensionally, certainly, in all of this. Sorry, yeah. Or over here, yeah.
Thank you very much. Very enlightening talk. It's a nice change to hear the engineers talk as opposed to politicians. I'm from the Kitchener-Waterloo area, and we're having similar discussions about a proposed light rail system through the corridor. And part of that discussion talks about how increasing this transit infrastructure changes development in the area, and specifically densification. So your talk about adding extra capacity in some areas with current ridership, there's a feedback mechanism there that if you change that intensity of transit access, that will drive changes in development and densification. So have you looked at models of that down the road, let's say 10 and 20 years, if you do make these changes?
Yes, it's a very important point. I didn't have time. I talked about sort of the one-way thing. If you have this urban form, here's how it translates into demand. But there is the feedback. By building transit, you are changing accessibility, and that will attract development. Now, the key thing there is it's not build it and they will come. It's not an automatic thing. You have to make it happen. You have to zone it. You have to encourage it. You have to work with developers, and it has to make sense in the market. You can't just wish it to be. But yes, one of the very important things about transit, it is a shaper of urban form, and indeed you can argue if you're going to be spending billions of dollars, hundreds of millions of dollars on these things, you better be using it as an urban form shaper. Otherwise, again, it's probably not a good investment. And Kitchener-Waterloo is a real example of that. The justification of the light rail really has to do with how you're going to reshape your cities. And I'm a big believer in that, quite frankly.
Yes, I'm Michael Hogan, and I studied under Richard Soderman also. And I consider the transportation system in the Greater Toronto Area a complete disaster. Of course, I'm a little bit of a controversial person because at this moment I've been removed from BEO Council, even though I was elected a year ago. Somebody's putting up his hand, doesn't want me to talk about this. That's okay. That's okay. That's okay. I just want you to know the background. It'll be resolved in the court on June the 12th. At any rate, this is a free country, and we like to have the ability to speak. And the transit system in Toronto is very, very seriously inhibited by the streetcars. Now, the streetcars have at least 10 disadvantages, starting with the fact that if one breaks down, everything behind it stops. And then in addition to that, you have to build tremendous infrastructure. The paved roads won't take the weight of a streetcar. So you have to build a concrete base for them, which really, if you add that to the cost of running the streetcars, it's double the cost of a bus. Why don't we have electric buses like we used to?
Okay, well, I don't think we have time to debate buses versus streetcars, but I would agree, and that this was a very rail-oriented talk. Buses, bus rapid transit, et cetera, are very much part of the technology mix as well, and we have to be, again, looking at the right technology in the right corridor. People are doing very interesting things with buses in many corridors here in Canada and elsewhere, and that definitely has to be part of the mix. I think you've been waiting a while.
Hi, Richard Schmira from the Brantford chapter PEO. Very interested in the complexity you've outlined here in this issue with transit in Toronto. And from my understanding of what you presented here, the concept is it's a complex problem, and you are basically saying that it's the consumer that needs to drive how it's resolved. I'm understanding that. And at the risk of comparing green apples to red apples, a couple years ago I spent some time on the subway systems in St. Petersburg and Moscow. And Moscow is a kind of a ring system with a star lines. And I was overwhelmed at how efficient it seemed, how, and it's not something, of course, that was driven by the consumer, probably planned many years ago by a central committee. Of course, everybody riding it was extremely unhappy, glum, I've never seen such a glum group of people, but my question is, how can you ever get to the same level of effectiveness when you have to deal with consumers who are very fickle?
Well, I think it partially relates to the previous answer with respect to Kitchener-Waterloo. It's a two-way interaction. And so by building a transit system, a transportation system with a certain form, you're going to shape demand. You're going to influence demand. But then the system will then have to respond to the demand that actually manifests itself. And so I think so there are both supply-side drivers and there are demand-side drivers. And I guess and so you can be normative and say, this is the shape of the city, this is where we're going to put things, maybe this is where we have to put things, and we're going to try to make it work that way. But the key thing is to be building both the urban form and the transit system ideally together. And I guess the emphasis on the consumer, I'm just saying you have to understand your markets. I mean, we're not starting with a blank slate. So there is an urban form out there. There is a demand pattern. There in particular employment lands, we spend a lot of time looking at where people live. We spend less time looking at where the employment is and maybe how to shape employment. Transit is even more dependent on concentrations of employment than it is concentrations of people. So maybe we should start thinking about the urban form we have, the urban form we want, and how one transit network, one transit technology or another will actually get us from here to there. So I think there's a normative aspect as well as just a consumer response form. Yeah, sure. Okay. Yeah.
Hi. Again, I'm very sorry that we're going to have to stop the questioning there. We're getting quite a bit behind time, and we have a lot to do this morning. Again, Eric, are you going to be here for lunch?
I'm afraid I have to leave.
Oh, I'm sorry. Okay, maybe if you have some question that you want to just catch Eric before he leaves, please do so, if that's okay, a couple of minutes. Otherwise, we'd like to take a break now of about 10 to 15 minutes and reconvene here for a panel. And